this exercise we're going to look at the probability density functions of the normal and the t distributions. We're going to select a value for our random variable x and calculate what the value of the standard normal is and what the value of the t distribution is for that value of x. We've selected values of x between -3 and +3 with steps of 0.1 between them, and why we've chosen that will become obvious as we go on. So let's start with the standard normal distribution, which has mean 0 and variance 1. And to calculate the probability density function, what you do is you enter the norm into Excel, and it will give you a set of options. What you want is the normal, standard, S for standard, dist for distribution. So click on that and it gives you some options. First of all, you choose the value of your random variable, Z, and then you tell it whether it should calculate the cumulative distribution function or the probability density function. We want the probability density function, so we just double click on that, and there we are. So that's calculated the normal distribution. With the t distribution, you go through a similar process, and again when you enter equals t into Excel, you get a set of options. You just want the t distribution, so double click on that and you select your the value for x, and then comma. With the t distribution, you also need to supply the number of degrees of freedom, and we're going to hold these in this cell here, cell C7, and because we want them to stay the same throughout the calculation of different values of x, we're going to have to lock that cell by pressing F4. Then we have comma, and again we want the probability density function, so we hit return there, and off we go. Now as we do the calculations, or copy the calculations rather, you'll see a graph appearing here. I've set up the graph to capture all of the values in the column where x is taking the values from -3 to +3. So if I just go down to the bottom here and go back up, you'll see the familiar curve of the normal and t distributions. The t distribution, if I change the degrees of freedom, I'll make it look more like the normal distribution. So if I increase up to 12 degrees of freedom, the normal and the t come closer together. If I make it 40, they're almost identical. Let's leave it at 6 so that we can see a difference. Now the range from -3 to +3 I've shown with grid lines for each interval that we've selected, and you can think of these grid lines and the height of the curve as defining very small rectangles, and we can calculate the area of these rectangles and then add them all together, and that will give us an idea of how much of the probability associated with the normal distribution and the t distribution lies between -3 and +3. So let me work out the area for the normal first. So the value for the normal is in cell B9, and I multiply that by 0.1, because 0.1 is the size of the step from -3 to -2.9. I'll do the same for the t distribution. Just apply the 0.1 again, and we calculate that down. Now I've calculated the areas of the individual rectangles shown on the graph. I'll add them up. Well, I've already set up a cell which adds up all of the areas of the different rectangles in D9 through to D69, And the answer is 0.998. So for the normal distribution, 0.998 of the probability lies between -3 and +3. And for the t-distribution, I've done the same thing, and the answer is 0.978. I've also calculated what's the difference between the area that we have calculated and 1, and that must mean that this amount of probability is outside the graph that we're showing. So for the normal distribution, 0.02 of the total of 1 when we add together all probabilities, they must add up to 1. 0.002 is outside the graph that we're showing, and for the t-distribution, the answer is 0.022, so almost 10 times as much probability is outside the graph for the t-distribution as for the normal distribution, and we would say the t-distribution has fatter tails than the normal distribution.